presentation on JupyterHub as a service using Docker and Singularity. What is JupyterHub? And the main goal is to have an easy interface for Jupyter users in HPC. JupyterHub implements spawning notebooks on demand for users. Notebooks support various kernels, Python, R, Julia, etc. So it's quite easy for users who are familiar with these languages and have support of the Jupyter notebooks. They can run basically their code on HPC with a couple of clicks. IPython parallel can be used to run parallel workers on the whole HPC with a batch system, which I will also show in this talk. And user-defined conda environments could be used as a kernel, which is also nice because users sometimes submit their jobs as a normal batch jobs on the system, and as well as they will be able to run tests using notebooks. Benefits of running JupyterHub backend with Docker. There's already Docker containers for JupyterHub deployment. You can use that. Can be deployed on any node or server in HPC or cloud. You don't have to have this backend web server running in the HPC systems. Many HPC centers don't want any web applications running on them. And you get also other benefits of running web services in containers. Benefits of using Jupyter notebooks in Singularity is that there's ready-to-use containers with pre-configured scientific Jupyter notebooks. Can run multiple versions of Jupyter with the same hub. The necessary environment for Jupyter is encapsulated. Containers with a Jupyter notebook can be prepared by users as well. So they can use software from their favorite software deployment channels or packaging utilities. Here's how it's done in GWDG. We have a user with a web browser who can access a JupyterHub server, which runs in the cloud. And then JupyterHub server spawns Jupyter notebook on the compute node using the batch system via submission node. So we have a single script there which has rights to use sudo, and then the script changes the user and submits this corresponding Jupyter notebook job. And then the JupyterHub server communicates with the notebook using proxy. So, and afterwards, as I said, there's possibilities to spawn the worker nodes or workers, IPython workers in this case, on the compute nodes using batch system again. There are several JupyterHub workarounds that we had to tackle and implement. We extended a batch spawner to allow submission from the submission node because by default it supports the JupyterHubs where they are deployed within HPC, or at least with the functional batch binaries that can submit jobs and kill them. On the submission node, there's a script with sudo, which I already taught, which only allows to switch the user and submit kill predefined notebook job. Singularity image definition file is public, and users can use this definition file to extend it and run their own containers using the JupyterHub instance that we are providing. And I will show you the live demo, how it works. So this is a landing page where you can spawn the notebook instance. Probably most of you are already familiar with something like that. You just select the profile. In this case, we have 3 options. You can use your own container if you have. In this case, for the presentation purpose, I will use IPython parallel version. You have several options, of course, to define the memory, CPU amount, and so on. And then we say spawn. It will submit using this in-between node, submission node, to submit the corresponding job on the compute nodes. Now we submitted our job, and I will create a cluster to show IPython parallel. I will run 8 worker nodes. Hopefully there are some nodes available because I didn't create reservation. Usually it's not needed. And I will open the notebook that I prepared. Okay, first we load the necessary libraries. In this case, it's IPython parallel. We choose the profile. In this case, it's Slurm because we use this profile. All that is pre-configured by administrators, so users don't have to do anything. It's exactly how users will use this or supposed to use this feature. So they don't have to write any configuration files, they don't have to write any batch files. They just need to click on spawn the workers and use this profile. And here is a simple hello world example, which just outputs the hello world from each worker. That means the workers are running now and they're functional, and JupyterHub can connect to them, or the notebook can connect them. We can use it in different manner. We can use direct view object. We can define functions. And when we use direct view, we can sync or call this apply sync function with defined function. So it will be called on all the nodes. In this case, because I didn't give large enough amount of workers, they all landed on one node, which is also fine. About the functions that you can run on them, then you can create decorators, which is quite useful. You can decorate the function with this direct view, remote, block true. There are multiple options. I will not go in details, but you can do that with decorators. So parallel func now is a function which is decorated and should run in parallel. And when we run it, you can see that it indeed does it 8 times on the same node. And here's a short example of Mandelbrot calculation. We just need some math libraries, Mandelbrot functions to calculate them, and we call or we generate some grid to generate the end result. And then we measure the time when we have it running on one node. On the current node where the notebook is running, so it took almost 3 seconds. And if we run the same thing but with function mandel2, which is decorated to run in parallel, we should get less. Yes, so it's less than a second and faster than running it on the node itself. And here's the results. So they should be the same, of course. Makes sense. And other easy ways to run things in parallel, you can call some functions like scatter. So it's quite useful. And you can also do some basic Python stuff there too. Okay, so that was the demo. Thank you very much, by the way, Nathan, for sharing the links. And as soon as I find my presentation, yes, I can go further. That's what I showed you. So we are in conclusion now. In general, JupyterHub in HPC is a well-received service. Weekly by our cluster in GWDG for university and Max Planck. There's 20 unique users every week. So it's not highly used, but it makes sense because computation should not be run in interactive mode. They should be submitted as normal jobs and running with a scheduler. But it's nice tool to have when you are developing something or testing. Also for visualization. And advantages are it's easier to access, to HPC for users familiar with Jupyter. It can be used as front end for other services like visualization nodes or something. Containers help for fast deployment. And disadvantages are that notebooks containers should be updated along with the software on HPC. So there's also that yeah, you need to keep the container or the notebook container at least up to date. If a functionality of containers is extended, then it should be compatible with the upstream version. So if you want containers to be up to date and extend them, then you need to also make sure that either you update it in such a way that it's compatible with the future version of the container, or you do something else. Okay, thank you very much. Are there any questions?
When you say cloud, are these your computers or actually in the cloud somewhere?
It's in the cloud by GWDG.
Okay.
Isn't it a security risk if you run this sudo command?
It is a risk, but it is only for one script, and of course you need to control that no other parameters can be sent to the script, and that nothing bad can happen, and also that maybe don't allow it on the nodes that users have direct access to.
Okay.
But it runs, of course, not for everyone, but for just a normal user on the HPC, and so it's not the sudos that should impose any security risks.
And maybe a further question, why do you run JupyterHub in a container? You can run it natively, so what is the reason for that?
For the easier deployment, because it runs in the cloud.
Okay.
We decided that we already had another JupyterHub instance, but not for the HPC, but for the Docker notebooks. And we decided it's much easier to use the same Docker image and just reconfigure it.
Okay.
From Jupyter VM to a container version on our, it's more comfortable.
I'm sorry, I didn't get the last part.
I think it's easier to for deployment too. It's to use JupyterHub in Docker containers.
Mm. Yeah.
So you can also make a copy or start a new instance of that, do some tests, and if it doesn't work, you can switch back to an older version that is more. It's easier than to use an installed version. So we also put a no VNC version and DCV in our JupyterHub, so that we can start a DCV session. I'm not sure if you know this is a OpenGL desktop environment, and you can start it with JupyterHub Notebook proxy. I think Jupyter Server proxy is a plugin you can use there, and also a Singularity container, which has integrated the no VNC desktop with XFCE or something like this.
Yeah. So it's quite a nice service to have, especially if you have or you want some entry points, graphical web-based entry points for the other services.
For all of you who have JupyterHub running, did you also make your HPC courses with JupyterHub, or so I thought about that to make a more interactive HPC course via JupyterHub, but sure if someone do this right now. So
yeah, we at least in GWDG we did some extended course where we provide how to work with JupyterHub and what it can do, especially with content environments and etc. But I would say that for general teaching, it's not a very good idea, because the point of teaching for the users is to make sure that they are able to work with cluster, with commands.
Sure, but you can use, for example, a bash kernel and put some batch script in a Jupyter Notebook and run them interactively, and so you can see the output there easily, maybe.
Yeah, now I'm thinking about it, and it might be a good idea. But then, of course, they will not be able, or the users who will learn how to work with JupyterHub, they will not be able to work with the cluster when, for example, JupyterHub is down, or there are issues with it. So
yeah, maybe because they do not know the step how to access the login nodes. But yeah, I think that's one point who can be learned by themselves.
Yeah, but I find it maybe useful for Windows users who doesn't have like native shell client, or don't
Windows
know
also has native shell nowadays.
Yeah, but sometimes they are provided by, for example, universities, and I mean the Windows machines, and if they're old and they cannot install anything on them, then it might be tricky.
Yeah, but all Windows 10 machines have native SSH.
Yeah, yeah, I find it interesting, but didn't think about that yet. Maybe we should do that.
So if you do that, then tell me. But it is also a good point, because your HPC course and our also only two times a year, and then they can get the notebook, go step by step through the notebook, and train their skills. And after that, maybe they can take that what they learned and go to the HPC system and working with the knowledge there.
I mean, we are in the discussion part already, so I can discuss it too, right?
Yeah.
I actually don't think that's a good idea to use JupyterHub or similar methods in the introductory course to HPC, because these introductory courses, I guess, they serve the same purpose for you as they do for us, to introduce new users to the HPC system should, in my opinion, prepare them to work as close as possible with the system. So also consider the hardware of the system, how to specifically tailor their SBatch scripts, so that the job files to the specific hardware and the MPI implementation, like hybrid or pure MPI or OpenMP, that their software is using. And this is, in my opinion, better done directly on the system and not by putting another layer between the users and the system with JupyterHub.
So if you use a bash kernel, then you can also put your hardware information there and your batch script there, and run it, and they can change it and also run it and see the difference, and that would be more interactively for learning, only for learning purposes. And yeah, maybe the users are not so, yeah.
I mean, it depends. I mean, in NHR, we only have like projected users, so users that have written a proposal. Yeah, and it's not like everyone in the university has access to the cluster. I mean, some universities and some clusters have that, but not in the context of NHR, where basically all the compute time is compute time attributed to a lengthy proposal. So maybe if you have general users, that's a fine course, but in the context of NHR, and you know the NHR proposals are already quite an investment, think you can start like a bit more to the bare metal or to the system.
Yeah. Yeah, now I'm thinking about it. Maybe indeed, for example, at least for the Slurm, commands, submitting the jobs and etc. Maybe it's not that bad to have it all in one Jupyter Notebook, where users can just go through the notebook and try all the commands, and it will output without going back and forth with the slides and or the course materials.
Might I make a suggestion?
Yes, please.
in SERM 2205, I believe it was, we added the ability to have JWT authentication so that a site could have this completely on the user land and then use the user's tokens to submit against the system without any additional security issues. Just a suggestion, but it might make life easier along with the REST API. I'm aware that the SSH wrappers and proxies are pretty well used already, but trusting users is not something we ever want to force upon a site.
Yeah. Yeah, with API, so then users actually can also submit jobs, not having an account, but for example, submit from the testing account if we just gave them this API keys. That's also very interesting. We should think about it.
Also, if you look at 2108, there's our first step of supporting JWKS keys. So using a central RSA to sign a key, and that way you don't have to share the keys out, and it's a lot easier, so you can just hand them out via another process. In a lot of cases, there's identity servers that handle this for you.
Yeah. Thank you. And regarding the thread with a discussion thread with regarding glibc, so I think it's already discussed in the chat, right? And I think it's only with respect to Charlie Cloud or anything else that swaps glibc libraries. I have never encountered the problems with Singularity or something else, or Docker.
I think the glibc discussion is very interesting because we use container also for getting in glibc for software that needed this, because on our system we only have CentOS 7, and when we have a look at EasyBuild toolchain, I think 2022 21 B, there are some software which I think it's Qt, which needs some newer glibc, and that is only provided with CentOS 8, and so we goes away and put that into a Singularity container, and that's also, from my point, a reason why to use a container, because then you can switch to a newer glibc, and yeah, but maybe I'm not really understand. So the problem is that when you link software from outside in the container, then there is an issue, right?
There's also another issue that's most sites haven't hit yet, but the dbus compatibility is going to be a fun one that sites are going to start hitting. You got KDBus, you got the system D1, you got the GWDG, I forgot all the names of them. As you go up in versions, it's going to have to be a consideration of making sure that dbus is actually compatible too. Luckily enough, this doesn't hit HPC jobs so much, but if you're running something like JupyterHub there, something that uses graphics, it's definitely going to be an issue in the not too distant future. And I don't have any suggestions as to how to fix that currently, other than actually running multiple versions of the other side.
Yes, changing glibc might be tricky. I mean, but I would say you need to update the host glibc, and if you are using quite old one.
Note also that cases where it is a CentOS 6, some sites have found the third type of containerization I suggested, where you actually run Slurm inside of a container, or at least a mount namespace that's of a newer install, and you can escape some of the issues. So even if you're on CentOS 6, you can run Slurm inside a container that's for CentOS 8. There will be driver issues, especially if you have like NVIDIA or Mellanox. But as long as you don't need the higher performance, you can at least get it to work.
Okay, thank you. So are there any other discussions that we left open? I tried to finish them all, but maybe I left some. So now is the time to open them again or discuss any other topic. Okay, then if it's not the case, thank you very much for joining the workshop, for the presentations. They were very, very nice. I enjoyed it a lot, and hope we will see you in the following up workshops during this week. And have a nice day, have a nice evening, and see you all. Bye-bye. And please, partners from NHR project, could you please stay a minute or two in the conference?